final contestant of the evening is Justin Beltz, a PhD student in chemistry, and he will be presenting to us on determination of drug penetration in ocular tissues for development of non-invasive treatments for cataracts.
Raise your hand if you've heard of cataracts before. Okay, so I see a lot of hands raised. If you're unfamiliar, cataract is the clouding of the lens that blocks vision. It's the leading cause of blindness worldwide, and in fact, cataract surgery is the most commonly performed procedure among Medicare patients in the United States. We kind of take it for granted and treat it like a solved problem, which is really unfortunate because it just isn't accessible to a huge portion of the world's population, especially in developing countries for patients that aren't healthy enough to undergo the surgery. So imagine if we could have an eye drop formulation that could be used as an alternative to prevent or treat existing cataracts. So how is this possible? If we take a look at the structure of the eye, light enters the eye through the pupil where it reaches the lens. And inside the lens we have these crystalline proteins. What these guys do is refract the light and help bend it onto the back of the eye so that we can see. Now these proteins are prone to becoming damaged over time by pollutants and exposure to UV radiation from the sun. So what can be done about this? In my research group, we investigate compounds that can protect these proteins from this type of damage. What happens when they're damaged? If you imagine that you are frying an egg, when you first pour the egg on the skillet, the white of the egg is clear. What's happening is, as you heat it up, the proteins are becoming damaged and they start to unfold and stick together. They form larger and larger clumps called aggregates that become so large they crash out of solution and form this opaque white solid we're familiar with. The compounds that we're investigating have demonstrated the ability to protect these proteins from this damage. So we're just left with one problem, and that is if we look at a lens under a microscope and look at its structure, we find it has a lot in common with both Shrek the Ogre and onions. Layers. Onions have layers and lenses have layers, and it's these layers that make it so difficult to deliver drugs to this part of the eye, because it has to diffuse and penetrate through all those different tissues. So we have a series of compounds that are effective, but we can't get them where we need to be. In my research, I've developed analytical tools that can be used to determine exactly how much drug reaches each part of the lens. And hopefully, in the near future, we'll be able to develop an alternative treatment so that these patients can see again. Thank you.